All right, so we talked about a linked list. Hey, look, there's some more linked lists. You have a head, it points to a bunch of elements, and I like how their arrow to delineate null points down. All right. And this slide is unfortunately confusing, which is why I don't like it. But what they're trying to point out is that head contains the memory address 1200. At memory address 1200, you have the value 45, and then next to it, you have a pointer of the memory address 1575. You jump over to that one, and then there's 65, and I guess empty is empty. But it really should be hex, because then we can easily tell the difference between the two. Oh, wow, they give you exactly what it looks like. They call them structs. Huh. All right. They call them info and link. Wow, I really don't like those terms. So let's actually go to coding this ourselves. All right, let's cp cursively make file to, are we on day 7? We'll call it the singly linked list. Wow, I need to clean that up. Whew. Okay, I'm gonna have to make a new a new template at some point in time, so I don't have to do this every time. All right, so let's first create a main.cpp. I wonder if we can make some music out of that. I can't think of anything. All right, so we'll call it the singly linked list.hpp. So I'll go ahead and if not define single underscore h. Ooh, got some more people. Nice. Go ahead and define it. And I'm putting this in here for those of you who don't recall. So if you accidentally include the header file twice, it only gets included once. Okay, so we need to create a node. They use structs. I think that's silly, so we're going to use a class. We'll call it the singly linked list node because we are not creative. All right. Now, what is this representing? Very important to understand. This node class is going to just represent this object right here. It is not representing the entire linked list. We're going to have it just represent this node right here. So what does this node contain?
A value and a pointer.
A pointer, right. And what's the values type?
Anything we make it.
Anything we make it. So you want to template this?
Sure.
Let's not template this for now. We'll just make them integers. All right, and then it contains so it has the value, and then it contains, you set a pointer, so that's great. We're gonna call that next. So it's a pointer to next, but what is it pointing to?
The next node.
The next node. Can anyone type what that is, what you'd put right here? This is gonna be the stretch for some students. Logging in. I know at least one of y'all is logged in. What's it pointing to? Oh, there we go, int. So that would be pointing to another data. But it's not pointing to a data. Let's go back to the picture. It's not pointing to another integer. What it's pointing to another node. So it's not an integer. Good guess though. All right, there we are. So it's pointing to another node. Anyone see a problem with this? Because that's a trick question. Yeah, it looks recursive, but it's not actually recursive. See, this would be wrong, because then you're defining a node to contain the node itself inside the node class, which would be infinitely recursive. This is okay, because you're actually telling the node that it's going to contain a pointer to another node, but you're not going to create that node, or you're not going to create it initially. You'll have to explicitly create it. Okay. So this is a node class. Let's go create some nice little helper functions. What do we have? We have int get val. Or do y'all prefer camel case or snake case? I can never remember. I keep getting the doesn't matter. Sweet. Ooh. And then public. Oops. Went back to Java. Let's see. So, oh wait, we want to be able to set them too, don't we? So confusing. Constant int val, and val equals val. All right, and then I don't know why I have a return statement on that one, but I sure do. Set next. Constant SL node. Ooh, that looks funny. All right, and then let's create a nice little constructor so we can make our lives easier. And set val to val, and then set next to next. All right, I put them all in the header file because I'm tired of typing. All right, great. How are we doing? All right, we should see if this actually compiles. So let's open up source main. I already forgot what I called it. Was it just sll.h?
.hpp.
HPP? Let's find out. Yeah. So let's type in make. Oh. Recipe failed for simple. Yep, I knew there's a problem here. No such file directory. Oh, okay, we're gonna have to fix that one. Oh, because there aren't any other source code files. There we go. Error invalid conversion from const to that. Oh, okay, so we can't make them const. Whew. Let's just get rid of const. It's annoying anyways. Perfect. All right, it worked. Hey, it ran. That means it worked perfectly, right?
Yeah.
Yes.
It didn't break.
There's not a single problem. Okay.
You're just the best in every way.
Yeah, that's it. Wow. All right. So let's create a node. We'll call it node. All right. What are we gonna do? 17 and whoa! How did I do that? Oh, that was cool. How did I do that? I have no idea. All right, and then we'll give it null. Okay, so I'm gonna go to the board and erase a lot of things. All right. So let's create a 17. So we created 17, and it currently points to null. Or more specifically, that. Okay. Great. Hey, let's see if that runs. It did. Well, maybe we should print something out. Yes. Let's just do this node.get val. Alright, so what should that print out? Probably should include IOStream. I put in standard IO. The number it should print out is 17. Alright. Not trying to be tricky. Just trying to make sure everyone's on the same page. Great. So, let's create a new node. We'll call it node 2, and we'll give it the value 20. 20. I got this. Then we'll call node.setNext to node 2. Now, does that require a pointer? It does require a pointer. So we're going to have to do that. Ooh, this is getting tricky. It compiled. So now, what happens when I go node.getNext.getVal? Hopefully. So pictorially, what I just did, make sure everyone's on the same page, I created a new node called 20 and put that to 0. Oh, because it returns a pointer. So since it returns a pointer, we have to do the arrow. Are y'all familiar with that syntax? You are. Y'all, okay, great. There, it's 20. Okay, we're doing great. All right, so now that we've talked a little bit about nodes, we want to create the linked list class itself. So I'm going to go erase my little node thing up here. So if we want our linked list class to represent a full linked list that contains nodes, what is the linked list class going to have? Called singly linked list. And this is to represent the entire linked list, whether it has 1 elements, 2, or 40 billion. What does it need?
Header and tail.
Header, well, it needs at least the head, right?
Yeah.
So we need, we'll call it mHead, and it needs to point to what?
The first.
Right, the first guy. Okay. So private, someone type out the mHead syntax for me. Don't worry, I'm just staring at all of y'all right now. Good first guess. Nice extra semicolons. But it's not pointing to an integer. What is it pointing to? We go back up to the picture. It's pointing to a... Would it help if I drew it like this? And then mHead points to this. Oops, that's not what I meant to draw. Does that make more sense? Less sense? More confusing? It didn't do a single thing? All right. I tried.
Bless you.
Bless you. So, mHead is, all right, did y'all Yeah, I wouldn't even look at the code. Yeah, okay, someone did it. Great. Perfect. Okay, let's just keep that for now. And let's do public. Let's think about what we want here. Well, we wanted to have a constructor, right? Yes. We want to be able to add, or let's call it push. Push back, bless you. Maybe push a value to the back, push to the front. We want to be able to find. I just realized these need to be void. I'll do, yeah, int contains. How about that? Whether it contains it or not. And I just realized that C++ has a Boolean value, so let's use that. And then we also want to be able to remove. Seem like things we'd want to do? Maybe? Oh, misspelled tab new. All right. Let's go ahead and fix this all up. All right, and then let's make sure that everything still compiles. Not quite. No return statement. Ooh, we didn't like that. How about now? Oh, it took it. Okay, good. Okay. So let's start over from here. So this is just us just messing around. So now we want to be able to create a singly linked list. We'll call it SSL. Boom. And then we'll probably want to do .add, or we'll do push back. What are we pushing? 17. And actually, let's do push front. I've decided that that's going to be easier. 20. Okay. So we create our singly linked list, and then we're going to call push front of 17, and then push front of 20. This is actually, let's say 19, because that is actually in front of 17 in the array picture. And then let me go fix that in the code so we're all on the same page. Ooh, that was cool. Okay. So what happens on this line of code? Well, we're going to create our singly linked list, and we're going to have mhead. And actually, that's all we're going to have for now. What's mhead going to point to?
No.
No. Right. Good. All right, someone type that in. Man, we're am I just scarier this time, or? It's funny how each class is different, because this one y'all seem to have a far better grasp of pointers, but coding in front of the class, man, y'all just don't know how to do it. Yeah, you can do it. Go ahead. I just want to. Someone besides me, otherwise I go on autopilot, and then no one can follow.
Who's going to judge your everything?
Yes. I'm right over your shoulder now. In head, right? I do the space bar next. No, because you don't want to dereference mhead. You need to set the mhead pointer. So you need to set it equal at all caps because this is C++. That's fine. Perfect. Great. Let's go down to push front. So in that piece of code, that's what we did. Great. Push front. What's the first thing we need to do?
Make a node.
Right, so step one, we make a node. Give it, there, we make a node. And we have a constructor. So let's go, I'll get this one kicked off for y'all. So we'll do node equals new. All right, and if y'all recall, the constructor took a value and what it points to next. So let me let y'all finish this. Well, I guess it shouldn't val. There we go. But what should its next be? Haha, too many people typing. It's the super null. Okay. Semicolon. All right, great. Sorry. I was getting excited. All right, and what that does, it creates 17 here and points that to null. Man, we're doing great. Now what do we do?
We have to change mhead to point to that one.
All right, so then we want mhead. Instead of doing that, goes like that. All right. Good first step. So we'll have mhead equal. What's mhead pointing to?
It's pointing to that cell node.
That node. So in the code, that is node. Someone type that. Good. All right. We're starting to break free of the scaredness to type in front of the class. All right. Okay, great. You know what? I'm completely wrong. I fell asleep. Oh, no, we're good. I'm sorry. I am tired, but y'all are right. Because we set mhead, we're good to go. All right, let's see what happens when we push front 19. What's the first thing that happens in the code right now?
It makes a new cell node.
Right.
That,
With the value 19 and pointing to null. And then what does the code do?
and then makes the mhead point to that.
Makes mhead point to this. Uh-oh.
There's an issue.
Yeah, what's the issue?
We completely detach the 17.
17's
Right.
a wandering.
Yes,
little node.
it's a little wandering node. And it will and now you have a memory leak. And also you don't have 17 either.
It's disappeared into the forest.
Disappears into the forest, never to return. Okay. So where did we go wrong? Well, I don't think it was, well, maybe it was the node creation. But at this point, I put the hump back on it. Our code is still correct because we have node over here pointing to 19. So what do we need to do?
Have a temporary
It's
pointer point to where 17 is, so you can save that location.
Oh, okay. I like where you're going. But pictorially, before we move mhead down here, do we need to do anything with this guy?
We need to change the null to point to the other one.
To
The
seven-
tail.
the 17. To 17. Well, we're pushing to the front. So is he always going to go to the tail?
Oh,
No, he's always going to go to,
no. What mhead's pointing to.
yeah, what mhead is pointing to. There's different ways to do this in the code. Any guesses?
Well, you could have 19 flip to 17 and then move the head to 19.
Correct. So, here, I'll put you back in insert mode. You got this.
I have no idea if my computer's dying.
Your computer's dying? I'm going to step over your cord. Oh, I gave it up. Okay.
Yeah. I forgot to
You
give
can take
my-
her laptop. Oh, yeah. I'm kidding.
Well,
So I think I have 2 buddy computers up here.
Okay.
Mine-
Anyone else? Where can we change this?
No, I don't think so.
Well, what does a constructor take?
Takes a value and the value that it's going to point to. or
And
that-
the node it's going to
or-
point to.
Yes,
And
that.
what should this node point to?
17. The
Right, to the node containing 17, which we currently have a pointer to called
Imhead.
mhead. So the easiest way to do this, in my opinion,
same null image.
like that. Now, another way to do this, by the way, is to right here go node that would be correct, but I think this, and that might be easier for you to understand, but it's more important, or it's simpler this way. By the way, why would this not work?
Because we've already made mhead equal to the node.
Right, and you would have had a circle. Do y'all see this, or you want me to draw this?
So you'd leave 17.
Right, well, in this case, if we did the code this way, mhead would point here, and then this pointer would point back to itself. Womp womp. So don't do that. That's a correct location, or just put mhead right there. Perfect. Hey, let's see if that runs. Not quite. Null was not declared in the scope. Okay, well, let's make it declared in the scope. Perfect. So, one very common thing that I highly recommend you do for all your data structures when you start creating them is to create a print function so you can debug to see if your program is actually working the way it is. Because we added a bunch of elements, but maybe it's working, maybe not. It'd be good to at least see what's going on. And there's different ways to go about this. Let's see. We can do a print. We'll do print for now, which is what I said. There we go. All right, how are we going to print this thing? Oh yeah, let me fix the screen, or fix the this thing. And then we had mhead point here, and then that went away to the wrong stack. How do we print?
We've got to figure out a way to cycle through all the nodes. and
Correct.
count them.
Cycle through. The words they like to use is traverse, but you're correct. Traverse. So how are we going to traverse the array, or the linked list? Woo.
My first thought would be to create like a temporary node, set that to dimhead.
A temporary node pointer.
Yeah.
No. And I'm going to call this one rover. Set it to mhead.
And then you would print out the value of that,
Mm-hmm.
and then that's where my memory fits.
So you print out the value, and then you go to the next one. Print out the value, go to the next one. And you know to stop?
When it equals null.
Yes, when you're null. Let's do that in a while loop first. Node val, okay. Sorry, whoever I just deleted. Rover equals mhead, while rover. I'll go ahead and put in the not equals null. Ooh, that would have been bad. And we'll go and put rover get val semicolon And I almost forgot the most important part. Rover equals rover get next. All right, so create the rover start head. While rover is not null, aka not to that null symbol, print out its value, and then tell rover to go to the next one. And it just keeps iterating down, traversing the linked list. So now that we have that, let's call sl.print. Let's see how it's not a member of STD. Did I not include IOStream?
You can include it in the other.
There we go. Hey, 1917, which is what we wanted. Great. So if we were over here and we pushed 87, then what should it print out?
87, 1970.
All right, we're going to do it this way just to show you what's happening. Hey, we'll print it off each time. Beautiful. How are we doing? Great. Okay. Let's do print back or push back. Because I push to the front, let's push to the back. What value do we want to push?
The one that's already in
20. All right, notice if I run this, it doesn't do anything with 20, which is nice because now we've already set up at least a manual test case. Haven't done the unit tests yet, but we set up a manual test case to show what we want it to do. And this is a good practice to at least create what you want it to do next and then make it happen. All right, so pushback. Okay. So we want to push to the back. The value 20. All right, what do we want to do?
Create a node.
Get rid of this. Create a node. And go to the back, so I'll put it over here. All right. So you want typing this, by the way? Yeah, someone start typing this. So we create a node. What are you going to put in that node?
Push it back to what you said.
Yeah, we're going to put in. Right. I'm not trying to be tricky. I just want to make sure everyone's on the same page. And then what?
Question, you put in nothing.
You put in nothing. Ah. Okay. And then what?
You point to node.
Point to
Node, null.
null. All right. So we'll have. All right. Okay, great. Then what do we do? Ooh, this is where we have to make decisions.
Well, if you had a tail node, then you could just.
Right. So we have one option is to maintain a tail pointer. What would the other option be?
Cycle through.
Cycle through or traverse through to the end. Do we have?
You don't have tail nodes. So.
Well, we can add one.
Yeah.
I mean, you're free to just, grow your data structure as you decide to. Which one? Do we have a preference? No, good. So we'll do the tail pointer because pretty much all. Because pretty much all linked lists maintain a tail pointer, except for the trickiest. Only the trickiest linked list maintains one pointer, which happens to be both the head and the tail because it's cyclic, but we'll get to that. All right, so we need to maintain a tail pointer. Well, that means we need to go back and update our other code in order to work with this tail pointer. Nice. Thanks. Whoever did that. Who did that? Thank you. All right, and you, great. So, well, the problem is if we push to the front, because mtail needs to be pointing to the 17. How do we know? And right now with our code, mtail points to nothing, but it should be pointing to the 17. How do we know when to update mtail? On push front. Because we have to fix our other function first before we can do this function now. Which is fine. M had what?
M head equals null, or when M head does not equal null, I guess.
I think you were very close. If mtail is null, that means that you're pushing the first element to this linked list, right? So you want to update mtail at this point. So then mtail equals the node, right? So in this case, what would happen is when you push the 17, which was the first one, it would go right here. And then when you push the 19, it would find out, no, mtail's pointing to something, I'm not going to update mtail. So then it would leave mtail alone. Great. Everyone following? Tracking? Excellent. All right, now we have an mtail. This is going to make our lives a little easier. So now we have an mtail. Go into this. So we create a new node. It's equal. Yeah, that's correct. It wants to point to nothing because it's going at the end. Now what do we do?
Change mtail's pointer, or what it's pointing to's pointer.
Right. Y'all got this? Come on, guys. You're doing great.
Actually, I remember this in the pair file.
Well, which we need to first do mtail, so mtail.
Oh, goodness.
It's the mtail tail.
It's the best.
All right, hold on, guys. Let me try it. Oh, no, you got it. You got it. You got this. mtail. Remember, mtail is a pointer, so you want to use the arrow syntax. Now, how do we set it on mtail? We created a function called, I think it was set underscore next.
Right, that's what I was.
Yeah.
That's what I was trying to remember.
Oh.
It's like there's a thing. I don't remember what it is.
Yeah, if I had more screen real estate, I'd just have them both windows up at all times, but that didn't happen. All right, and what's the next going to be? Good guess, great guess, but node is already a pointer, right? So if you ampersand in front of a pointer, you're going to get a double pointer. So we don't need the ampersand because we already, node is already a pointer.
Right.
So let's get rid of the ampersand real quick. Perfect. Okay, so on the board what we just did was this. Are we done?
We need to have the tail point there.
Correct. So we need to do that next. Good catch.
Mtail equals good.
Yes. Oh, and then we go up here. Oh, and the function terminates, and we're up here. All right, does that look good? That looks pretty good to me. Let's see what our print function does now. Not quite. mtail was not declared in the scope. Oh, you know what we didn't do?
Did not declare.
And I highly recommend with pointers to just make them separate. You'll make this, otherwise you'll get your syntax confused because it's a little weird how it's done. All right. Hey, the 20 went in the back. How about that? And then we can go over here, and what else can we add? 1375. $13.75. All right. Looks good. How are we doing? Great. All right. Let's go and pause that video.